Today we are going to talk about emission spectra and atomic energy. You've all seen those gas-colored lights hanging outside restaurants, bars, or other places. Pretty much any place that has an open sign frequently has one of these gas-filled lights as their open sign. And you might have wondered what gives those different lights their colors. How come they have all the different colors? Um, the same principle, which we'll talk about a little bit later, can be applied to fireworks. What gives the fireworks their different colors? But thinking just about these gas lights, basically what is happening is an electric current giving energy is passing through the gas in each of these glass tubes, making them glow with a specific color. Um, every element on the periodic table has its own specific color spectrum, just like all people have their own specific fingerprints. And by looking at those specific spectra of colors, scientists can determine what an element is. In these signs, all those tubes are filled with different gases, which is why sometimes they're called neon signs because neon is one of the gases that is used. Um, However, it's not the only gas because each different gas element glows with a different color when it's given energy. So basically, what is happening there at the atomic level is those atoms are absorbing energy. And when that happens, their electrons in the different energy levels move up to higher energy levels. And then they will move back down to a lower energy level by releasing energy. The energy that they release is in the form of light, is light energy. So they give off that light energy in different colors. So you can see here, um, you probably have all seen a diagram something like this before, but basically you have light and it's going through a prism, and that prism separates it into its rainbow of colors. That's when you just have white light, like from a light bulb. Um, but if you have light from a very specific element, um, basically, like this picture here is almost the same, except now we don't have white light here, we have a hydrogen lamp. So it just has hydrogen in it. That's the only element inside this little container here. When you add energy to it and excite those electrons, it gives off light. And if you break that light up through a prism, you see here it just has these four colors: a violet, a blue, a green, and a red. So this is what's called the emission spectrum of hydrogen. It is the colors that hydrogen gives off when it releases energy, and it's unique like a fingerprint. Only hydrogen looks like this. All the other 118 or so elements have their own specific spectrum of light that they give off. We'll show you some more examples here. This is helium. You see it has a few more colors than the hydrogen. And I'll throw the hydrogen one back up here so you can see the difference between helium and hydrogen. Um, Here are some other ones. Um, Again, here's hydrogen with its four distinct bands. This one is sodium right here, calcium, and then mercury. So you can see they're all very distinct and unique. Um, Chemists can use this information uh, just like they would if a police officer goes to a crime scene and takes fingerprints and then runs those fingerprints through a database to try and match them to known people's fingerprints who are on file. The same can be done with different compounds. So, say they find a white powder at a crime scene, they're not sure what it is. They have very sophisticated equipment that basically will shine a light through that powder. This is a kind of a simplistic explanation, but and you'll get this spectrum of all the different elements. Sorry about that. I got interrupted. So scientists can take the unknown spectra, compare it to known things, and determine what a compound is. They do that a lot for drug testing. A very kind of unsophisticated, crude way to see these different colors is just by using a Bunsen burner flame, or any flame really. But you see here is just the gas coming through the Bunsen burner. This one happens to be. If you put just a piece of wood in there, you can see the color that it burns. If you add different elements to that wood, sodium you can see burns a nice bright yellow. Copper burns a green color. Strontium burns a very bright red, and calcium burns a nice orange color. Um, so, just by using the energy from fire as opposed to the energy from electricity to excite the electrons, and then as they move back down and give off that light, you can see the different colors of light that are given off. Um, and this is a little bit more about how fireworks work. Um, so the nice, bright, brilliant colors that you see in fireworks are all because there are different elements in there. And when they burn and get that energy, they give off different colored light. So this is kind of the picture of the inside of a firework. You have a fuse, and then down the center, you have these time delays, so it doesn't explode right away. It waits until it gets up in the air. And also, there's different things they can do with that. If you'll see them, they burn one color and then a different color. That is all to do with this time delay stuff in the core. There's also black powder in the core, which causes it to explode. And then the different chemicals that cause the green or the red or the white. Um, so all those are just different elements that burn at different colors to make those fireworks. So you can kind of see here sodium, that bright yellow, calcium is nice and orange, strontium is red, barium is green, copper's kind of a blue green color. But all those different colors just come from having different elements that give off energy at different colors of light in the fireworks when they are sent up into the air. At an electron microscopic level, here's what is happening. I know you've watched some videos that talked about these energy levels, but you have an electron at the first energy level, and as it absorbs energy, it moves up to a higher energy level, and then that energy is released, and it is released as light. So the light that comes from every atom happens when it loses this energy. So the energy can be absorbed can be heat, electricity, but when it is lost as light energy.